Hello everyone, welcome to the next lecture on the partial differential equation. Today I will give you the brief idea what is the first order differential equations, partial differential equations, where you can use in the day-to-day life and what are the various ways you can define and find the solutions. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel where you can find the playlist of the partial differential equations. You can see we have defined the physically concept of the partial differential equations, linear and non-linear, order and degree, and many more lecture in this playlist. चलिए फर्स्ट ऑफ ऑल आई विल गिव यू द रियल लाइफ एग्जांपल मोटिवेशन. जैसा कि आपने सबने इस प्लेलिस्ट में भी देखा, मैंने हर वीडियो में स्टार्टिंग के 2 या 3 मिनट आपको एग्जांपल बताई है जिसका टाइटल से क्या लिंक है. फाइन. मान लो आप एक गाड़ी चला रहे हो. फाइन. सपोज यू आर ऑन ए हाईवे फुल ऑफ द कार्स. फाइन. और अभी यहाँ पे आप देखो एट ए टाइम t इज इक्वल टू 0 गाड़ी आपकी सिंपल स्पीड पे चल रही है. मान लो किसी एक टाइम पे whenever the time is greater than 0 कहीं पे ये वाली रेड गाड़ी जो है वो रुक जाती है. सपोज द ठीक है, तो क्या होगा, डायग्राम कुछ ऐसी हो जाएगी. फाइन. एट वन पॉइंट द ड्राइवर स्लोली सडनली स्लो डाउन द कार. फाइन. सडनली स्लो डाउन द कार. सो व्हाट विल हैपन टू द नेक्स्ट. क्या हो सकता है आपके लिए, आपकी ऑब्जर्वेशन क्या होगी कि अगर कोई रेड, सपोज दिस द रेड कार, ही स्लो डाउन द कार, व्हाट विल हैपन. So can you say that does the jam study at the one point, उसी पॉइंट पे जाम हो जाएगा, और does it move backward. क्या ऑब्जर्वेशन आपकी. पहला पॉइंट, क्या आपका जो भी ट्रैफिक पे जैम है इट्स अ स्टे एट द वन पॉइंट. डेफिनेटली नॉट. दे आर मूविंग अ वेरी स्टडी स्पीड. ठीक है, धीरे धीरे चलता जाएगा ना आपके पास. एंड डज इट मूव बैकवर्ड. यस, बिकॉज जैसे यहाँ पे स्लो हुआ, इसके पीछे जो भी आपके पास गाड़ियां हैं दैट इज मूव वेरी स्लोली. फाइन. दैट इज अ स्लो डाउन बट ट्रैफिक ऑपोजिट टू द डायरेक्शन ऑफ द कार. अब आप इस एग्जांपल से क्या समझे आप. दैट मीन्स यहाँ पे क्या देख रहे हो आप, दैट इज अ मोशन ऑफ द व्हीकल, motion of the vehicle with respect to the constant speed c. So whenever you can see the traffic density depend upon the position and the time, that means it has two variables, and whenever it has the two variables, that means the traffic density I call as a u is dependent on the two parameters x and t. Therefore we can define the partial differential equations corresponding to this traffic density. और वो ट्रैफिक डेंसिटी की इक्वेशन क्या बनेगी, del u by del t plus c del u by del x is my 0. And if you look about these partial differential equations and clearly say what is the order of the first order of this differential equation. 1. What is the degree of this differential equation. 1. Whether it's a linear or the non-linear. This is my linear partial differential equations. For more details मैं फिर कह रहा हूँ, आप लीनियर एंड नॉन लीनियर का लेक्चर सुनिए एंड ऑर्डर एंड डिग्री का लेक्चर सुन सकते हो आप. फाइन. एंड व्हाई वी कॉल एज द फर्स्ट ऑर्डर partial differential equations, you can see what is the order of this differential equation, that is my 1, and that's why this partial differential equation is called as first order partial differential equations. Fine. Now how we can define it in mathematically. Suppose you have the two independent variable x and y and the one dependent variable, either you can write as a z or you can write as a u. Fine. So that means z is dependent on x and y, or if you consider the u, then u is dependent on the x and y. Fine. Then what is the general equation of the PDE? We all know the function which are dependent on the independent variables and the dependent variables. So I use the notation throughout the lecture. Wherever I have used del z by del x, that is a partial derivative of the z with respect to the first variable, I denoted as a p. Q with respect, q is the partial derivative of z with respect to y. If you consider second derivatives, then we call as a r, s and t. But क्योंकि ये लेक्चर फर्स्ट ऑर्डर का है, तो वी ओनली नीड द p and q. जनरल फॉर्म क्या होती है किसी भी पार्शियल डिफरेंशियल की, एनी फंक्शन which are dependent on the independent variables and all the dependent variable. These are my dependent variable. F is any arbitrary function. फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन इसको कब कहोगे, फर्स्ट ऑर्डर. दैट मीन्स whenever the order is 1. तो अगर आप इस इक्वेशन में देखो, इसकी ऑर्डर 1 कहाँ तक है, सिर्फ यहीं तक है ना ऑर्डर 1, बिकॉज जेड एक्स एक्स, इसका ऑर्डर कितना हो जाएगा आपके पास, order is my 2 because 2 times derivative हो गया. And once we are defining the first order differential equation, any equations which are defined dependent on x y z, zx and zy is called as the first order partial differential equations. Or if the highest order derivative present in the partial differential equation is of order 1, then we call as the first order partial differential equations. For example, here यहाँ पे आप बात देखो, यहाँ पे सिर्फ ऑर्डर की बात हो रही है. डिग्री कैन बी एनीथिंग, डिग्री मे बी 1, मे बी 2, मे बी 3. फाइन, लाइक जेड एक्स बाय फाइन प्लस इसका ऑर्डर 1 है. फाइन, दैट मीन यस इट्स अ फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. बट इफ आई राइट, क्या ये फर्स्ट ऑर्डर पार्शियल डिफरेंशियल इक्वेशन होगा? बिल्कुल होगा. फाइन, बिकॉज द ऑर्डर इज 1, डिग्री कैन बी एनीथिंग. So that as we can define the general form to the first order is x, y, z, zx and zy. That is only up to this part. And zx I have denoted as a p and q. Or in other form, I can write as in the form of the equation a into zx by zx, partial derivative of z with respect to x, b into partial derivative of z with respect to y is a c, where a, b, c are either as a constant or as a function of the x, y and the z. For example, you can see, is the first example is the first order partial differential? Yes, because it involvement only in the p and q. Yes, it is my first order partial differential equation. Is the second one? Yes, it is true. Third one, yes, p is there. Fine. It is also, all are the examples of the first order partial differential equations. Another examples are, suppose you have the wave which are travel along the x-axis with the constant speed c, like in the second part. This is example A. Initial wave at the time 0, and whenever the time is increases, the wave is wave is moving with the speed c. Then you can write that the speed or the wave, that means the speed is dependent on the position as well as the time. Now the speed I denoted as a u, or you can denote it as a z. They are dependent on the 2 points or the 2 variables. So yes, we call as the partial differential equations, and the equation is called as first order partial differential equation. Similarly, if you are moving on the transportation of the quantity, suppose at the time t is equal to 0, the some industries or the wind is flowing in the direction c, and again you can see the equation is my first order partial differential equations. Similarly, if you consider as the some another real life examples of the signal propagation in the cable, find at the signal at the time t is equal to 0, and at the later on it move with the speed c, the equation is again the first order partial differential equation. Now, based on the first order partial differential equation, we can classify into the linear and the nonlinear. How we can classify the linear and nonlinear? That is based on the degree of the differential equations. Fine. Linear partial differential equation means whenever the function f, which involvement of the p and q are of degree 1, that is called as a linear. Whenever p, q and z are of the degree 1, then we call as a linear partial differential, and whenever the partial differential is of more than 1, then we call as a nonlinear partial differential equations, like del u by del x plus del u by del y is equal to 1, and del u by del x whole square plus del u by del y is 1. फाइन. क्या ये दोनों आपके पास फर्स्ट ऑर्डर पार्शियल डिफरेंशियल है? तो इसका ऑर्डर देख लो पहले. व्हाट इज द ऑर्डर ऑफ दिस पार्शियल डिफरेंशियल इक्वेशन? 1. इसका ऑर्डर कितना है? अगेन 1. तो यस, दे आर द फर्स्ट ऑर्डर पार्शियल डिफरेंशियल इक्वेशन. इसकी डिग्री कितनी है? 1. हर टर्म की 1 है. सो दैट इज द एग्जांपल ऑफ द लीनियर पार्शियल डिफरेंशियल इक्वेशन. और यहाँ पे इसकी डिग्री कितनी है? 2. दैट इज अ नॉन लीनियर पार्शियल डिफरेंशियल equations, and the various examples are in this form. Find x, y, और पी, आप देखो पी, क्यू और जेड, इस सभी एग्जाम्पल में सबकी डिग्री 1 है। फाइन। और यहाँ पे देखो पी स्केयर लिखा हुआ है, पी स्केयर है साइन ऑफ पी, साइन ऑफ पी इज अ नॉन लीनियर, पी स्केयर, पी प्लस क्यू होल स्केयर, दीज आर द एग्जाम्पल्स ऑफ द नॉन लीनियर पार्शियल डिफरेंशियल इक्वेशन। अगर आपका वेरिएबल जेड जो है वो मोर देन 2 वेरिएबल पे डिपेंडेंट है, z1 x1 x2 x3 एंड सो ऑन, देन द फर्स्ट ऑर्डर पार्शियल डिफरेंशियल इक्वेशन इज a1 del z by del x1, a2 and so on. Fine. Again, a1, a2, an and the c are either the constants or the functions of the x1, x2, x3 up to the xn. Fine. Based on the behavior of the a1, a2, an and the c, we can classify the given PD into the 4 different categories. ये 4 कैटेगरी सिर्फ इसके बिहेवियर पे डिपेंड करेगा, लाइक वेदर इज ए कांस्टेंट, whether is a function of the x and y only, whether is a function of the x, y and z all, or whether the degree of the x is x square or z square or so on. Find similarly for the a, b, c and so on. Based on the nature of this a, b, c, we can classify the given PD into the 4 different category, and that is called as the classification of the first order differential equations. और इस क्लासिफिकेशन ऑफ फर्स्ट ऑर्डर डिफरेंशियल को हम नेक्स्ट लेक्चर में डिस्कस करेंगे. Till then, you can watch my previous lectures very deeply so that you can understand the concepts of the PD from the scratch. Fine. I hope you can like my video. You can share this video with your friends. Happy learning, students. Thanks for the watching. Best of luck.